Uh, Good evening. This one topic that is pending in the third unit, which is the virtual LAN. So we'll try to understand what basically virtual LAN is and what is this concept of virtual that we are bringing into LAN and what is that we're going to gain out of this concept of virtual LAN. So getting into the topic, so far, we know that we create a local area network based on a geographical area where we connect several workstations and share our data. Now here we're going to do something where we're adding a term called virtual, meaning there's something where not just by physical wiring we're going to do, but there's some software implementation that you're going to bring within local area network. And why are we going to do that by configuration in software? We will try to understand. Okay, so let's try to understand this now. I think you remember we use some terms like collision domains and broadcast domains. So what you basically mean by collision domain is what typically happens when you have these layer 1 devices like hubs or repeaters is when you have multiple stations which are say connected through the hub, and hub does not have any intelligent capability. So what happens is when most stations are trying to send frames at the same time, it gets collided at the hub, and hub basically does not do but just propagate the collision signals throughout the network. So what is typically happening here is you need to detect the collisions and have to retransmit all the frames. So this typically is going to waste your resources, the bandwidth that you basically have, as well as the time aspect is actually going to be wasted. So how did we avoid, or how did we limit the collisions, is to bring in the physical device or the layer 2 device where bridge and switch actually partition these collision domains, right? So what typically happened is it does not forward the collisions through the other ports. Happens in a particular port, the collision, then you actually limit that, because bridge or switch basically has this inherent capability of filtering the frames, right? So accordingly it tries to forward the frames to the port that it has to forward. And so when there is a corrupted frame that gets in, it's basically trying to filter out, and so the collision is actually being restricted. But the layer 2 device also has a major drawback. Now with respect to say broadcast or multicast frames, I typically say you're working as a project group. Okay, and you guys want to form a group, or you want to broadcast to all your workstations within your group certain information. But the drawback of the bridge switch is that when a broadcast frame or a multicast frame comes on in the destination address, the layer 2 device, which is basically the bridge or switch, does not know what to do, and it actually goes on to forward across all the ports. And so there is no limitation limiting or filtering the broadcast frames or multicast frames in these ports. And so that typically is again a problem, where when you need to limit the broadcast packets over the network, you need to bring in a layer 3 device, which is where you know the layer 3 is basically where it contains the broadcast packets. So that becomes a very, very costly solution, where you need to limit broadcast packets by installing just router. What we are trying to do here is we are trying to bring in a kind of a software configuration of how can we typically logically segment LANs into multiple broadcast domains. Now this is the idea. We have to understand this. Now when I was talking about the spanning tree algorithm in the bridges, what basically happened is that you wanted to avoid the loops, and so you didn't physically remove the cable, but instead you logically disable the ports. So this is something where you were able to achieve reliability through redundant solutions. Typically here, when you have a group where you need to do broadcast, but typically when there are so many such broadcasts being happening inside the network, what happens is that there's too much of traffic that actually goes and incur at the router level. So this, we need to have a software level configurations where we can actually go on to build multiple broadcast domains logically, rather than through physical segmenting of LANs through router solutions. So that's basically the idea that we are going to talk about virtual LANs, where when you take a LAN, you call it as a single broadcast domains, which means only a layer 3 device can actually go on to split the broadcast domain, not the layer 2 device. So what happens is that when you actually have too much of traffic, coming at the layer 3, the router processing also is quite slow. Why? Because it has to look through the IP address of the packets, look into its routing table, do a lot of processing of which subnet or which interface it has to forward the packets and all that. So generally the routing processor is slow, and when you have a lot of broadcast streams also coming in, and then router has to limit it, we can try to limit such broadcast traffic and through logical solutions. So this is the drawback that we have. The broadcast domain basically depends on the physical connection of the devices in the network. So the alternate solution is the VLAN, where instead of physically limiting the broadcast domain by bringing in the layer 3 device, let's try to come up with a logical solution or a software way of implementation to contain broadcast traffic or multicast traffic. And that's basically VLAN for you. Now this is just a picture where we can go on to see that there is basically some hubs, and there are a lot of stations connected to one of the port in the switch, and